So lesson 8.5, page 157, problem 23. So you have this swing holding a person. We're just going to think of that whole thing as like the object, and it's held from a cable. And it's like a swing ride, and it's going around a circle. And if you draw a free body diagram of the object at that particular location, there's only two forces acting on it. The weight of that whole object, which is going to be m times g, which is going to be 179 kilograms times 10 meters per second squared. So that's going to be 1,790 newtons. So the weight force, and the only other force acting on it is the tension force. So job 1, we drew a free body diagram. Job 2, ask the question, what's providing the centripetal force? Well, if that object is going in a circular path like this, then we know that there has to be an overall force acting inward towards the center of the circle right here, C. So what's providing that inward force right there? Well, this force due to gravity is perpendicular to that. So there's no part of the force due to gravity that's providing the centripetal force. So that's not doing it. So we see that the tension sort of is going to the left, and it's sort of going up. So it turns out to be the horizontal component of the tension. So what's providing the centripetal force? The tension in the x direction. So then we come over here and we're going to apply Fc equals mv squared over r. So let's see, did they give us the angle there? Yes, 60 degrees. So this angle here is 60 degrees. So if that's 60 degrees, if we draw these two components head to tail, so I'm going to pick the vertical component and I'm going to redraw it over here. So then here I have t in the x direction, and here I have t in the y direction. So I just took that t vector and I broke it up into parts. And this top angle right there is going to be 60 degrees. So knowing that, I know that Tx is going to be T cosine. No, actually, in this case, Tx is going to be T sine theta.
Oh, because that's getting good. Could you use 30?
You could use 30, but I'm just going to stick to the 60 there.
Okay.
So they told us this top angle here is 60, and it's the angle between the cable and a vertical line. So here's that same cable here, and there's a vertical component right there, so that's still 60 right there. So if you look at SOHCAHTOA, Ty is going to equal T cosine 60, and Tx is going to equal T sine of 60. If you have to go back to do regular SOHCAHTOA to see that to be true, take the time to do that. Now, we know over here that Tx is going to be providing the centripetal force, and that's going to be equal to mv squared over r. But the trouble is, we don't know what Tx is. And we come over here, if we knew what T was, we can get Tx, but we don't even know what T is. But we do know what Ty is, because what does Ty have to be balancing out? Fg. So Ty going up has to be balancing out Fg going down. So we know that Ty, which happens to equal to T cosine 60, is equal to Fg. So if we solve that for T, we know that 1790 newtons is going to be equal, I'm just doing this right here, it's going to be equal to T times the cosine of 60 degrees. So we could solve for t just by that fact alone. Anyone have that by chance?
3.580 newtons.
And now that we know what t is, we can come back over here and figure out what tx is. Tx is going to equal t, which is 3.580 newtons times the sine of 60. And when you crunch that out, what do you get?
3,100.37.
3,037?
No, 0.37.
Oh,
Like 3,100.37.
3,100. Like that?
Yeah, if you believe it like that.
Yeah.
0.37. I'll just leave it like that. Newtons. And then the mass is going to be 179 kilograms. And the velocity is what we're going for now. But we still have to figure out what that radius is. Now, they told us that the length of the chain of the cables is 15 meters. So we know that this right here is 15 meters. And if that's 60 degrees, we can figure out what this whole radius is right there. So we have to do a little trig there, and what trig function are we going to use? Sine. So we know sine of 60 equals r over 15. So r equals 15 meters times the sine of 60. Does anyone know what that r comes out to be? 12.99 meters. So then r over here is 12.99 meters. And then you have that whole thing, and you can solve for the velocity. Does anyone know what that comes out to be?
15 meters per second.
Okay, so the bottom line in this problem, there's two forces acting on the person here, the tension and the weight. If you break that tension up into parts, the upward part of the tension is equal to the weight, and the horizontal part of the tension is providing the centripetal force. So that's the key to this problem. Tx is equal to Fc, and Ty is equal to Fg. Do you remember it now?